Have you ever wondered how Amazon, Netflix, Spotify suggest you the items you might be interested in? And how do the things you want to buy are on the top of the search page? This is the magic of recommendation systems, and companies are using this fuel to power their growth. Hello champions, and a warm welcome to everyone tuning in. In today's video, we'll learn about recommendation systems. So without further ado, let's get started. You will gain an understanding of what recommendation systems are, the life cycle of recommendation system, the types of recommendation system, benefits of recommendation systems, and how does this recommender system work. A recommender system is a class of machine learning that uses data to help predict, narrow down, and find what people are looking for among an exponential growing number of options. Recommendation engines provide a personalized user experience by helping every single customer identify and discover their favorite movies, TV shows, digital products, books, articles, services, and more. These systems help businesses increase sales and benefit consumers. Because of the capability to predict consumer interest and desires on a highly personalized level, recommender systems are a favorite with content and product providers. They can drive consumers to just about any product or service that interests them, from books to videos to health classes to clothing. Even though the complexity of recommender system varies based on its functionality, such as recommending videos or suggesting items, many follow a 7-step path to develop a successful recommendation model. And those steps are collecting the data, store the collected data, filter the data, analyze the data, evaluating and testing our model, deployment of the model, and online machine learning. The first step is to identify and collect data relevant to recommendation system. For example, Amazon can collect reviews and product ratings, which is 5-star rating system, while Netflix stores watched, liked, and bookmarked shows and movies. The second step is to store data in a dedicated warehouse or utilize third-party cloud services providers like Amazon, Google, MongoDB, etc. for enhanced efficiency and faster data retrieval speeds. The third step includes removing problematic values from the dataset to enhance the model accuracy. For example, the employees working on recommendation system eliminate any instance where customer ratings are labeled as null or infinite. This data refinement process significantly boosts the precision of the recommendation engine, resulting in more dependable product suggestions for the users. In the first step, data analysis takes place. In the case of recommendation system, analyzing data means feeding it into the machine learning or deep learning algorithm that can detect hidden insights and patterns. The fifth step involves model evaluation. During this stage, the performance of the recommendation model is assessed. If the model performs poorly, then we have to tune the hyperparameters to the desired performance. In the sixth step, the model is ready to be used in the real-world situation, and the model is deployed in the cloud. In the seventh step, after the model is out there working, online machine learning comes into play. This helps the model keep getting better and adapting based on the new data it receives, ensuring its efficiency over the time. While there are vast number of recommender algorithms and techniques, most of them fall into these broad categories: collaborative filtering, content filtering, hybrid filtering, and context filtering. The collaborative filtering method focuses on similarity between different users and items. Consumers who share an overlap of similar interest will more than likely to be interested in other similar products. These similarities can improve recommendations to all users within the dataset and continue to learn as the new products come into the market. There are several types of collaborative filtering, and those are user to product filtering and user to user filtering. Recommender systems create a model based on users' past actions, like things they have bought before or the ratings they have given. They also consider similar choices made by other users. The concept is that if people have made similar choices before, such as picking a movie, they'll likely agree on the future picks too. For instance, in the given example, the second and third person both liked watermelon. So the system suggests a pineapple to the third person since the second person also liked it. User to product filtering, also called item-based collaborative filtering. It is the simplest of all the filtering methods, in which the algorithm will look for similar items that a consumer previously purchased or liked. Genre, price, item category are all categories that influence filtering. The example provided highlights the distinction between user-based and item-based filtering. In user-based filtering, recommendations are based on the similarity between users, whereas in item-based filtering, the focus is on similarity between products. Content-based filtering, by contrast, uses attributes or features of an item to recommend other similar items to the user's preference. This approach is based on similarity of item and user features when information about a user and items they have interacted with model likelihood of new interaction. For instance, if content filtering recommender system notes that you enjoyed romantic comedies, it might recommend another romantic comedy movie to you. The cold start problem occurs when there is not enough preference data. The recommender system cannot accurately suggest great option when you initially implemented on the platform, since it takes time to gather and train. Content filtering or similarity based recommender systems will suffer from cold start problem. Hybrid filtering utilizes both collaborative and content based filtering, utilizing the advantage of each other. Several studies comparing the performance of hybrid filtering systems with collaborative and content systems alone have shown that hybrid systems have better accuracy. Combining multiple algorithms can remove multiple issues like cold start problem and help gather data quickly. Many of our favorite sites like Google, YouTube, Netflix utilize hybrid filtering in their recommendation system. Content filtering is an approach used in recommendation systems like those used by Netflix to provide users with more personalized and relevant recommendation system. Instead of just looking at the user's past actions or preferences, context filtering takes into account the broader context in which those actions occurred. In the case of Netflix, they have adopted a technique called contextual sequence prediction to enhance their users' recommendation system. This technique involves treating recommendation process as a prediction task, where the goal is to predict the likelihood of the next user action in a given sequence of actions. These actions can include things like country they are in, the device they are using, the specific date and time when they watched a particular movie or a show. On top of the historical sequence of actions, the current context is also considered. This could include information like user's current location, the time they are watching a show, and other relevant factors. The idea is to consider not only what the user has done in the past, but also the circumstances surrounding the current situation. With this combined information, historical sequence of actions, and the current context, Netflix trains a machine learning model. This model's task is to predict what the user's next action might be, such as what movie or a show they are likely to watch next. Recommendation systems play a crucial role in the present era of online products and services. They serve as essential elements that enhance personalized user experiences, foster great customer engagement, and provide valuable decision-making support across various sectors including retail, entertainment, healthcare, finance, and more. On some of the largest commercial platforms, recommendations account for as much as 30% of the revenue. A 1% improvement in the quality of recommendations can translate into billions of dollars. Companies implement a recommender system for a variety of reasons, including improving the retention, increasing sales, lower system load, and increasing engagement and satisfaction. By continuously catering to the preferences of users and customers, businesses are more likely to retain them as a loyal subscriber or shopper. When a customer senses that they are truly understood by a brand and not just having information randomly thrown at them, they are far more likely to remain loyal and continue shopping at your site. The number one reasons why companies invest in such system is to generate revenue. Various research studies shows increase in upselling revenues from 10 to 50% resulting from accurate, you might also like this product recommendations. Increasing the sales through recommendation systems also increases customer engagement on their site and captures longer session time. As the system does filter the most matched items for each given user, recommendation systems improve sales while maintaining a lower load on the system and decreasing the cost required to run that system. By continuously providing consumers with endless array of personalized products, the consumers will continue to engage with the application or the website. Recommendation systems optimize the experience to reduce the page load with related content. Given everything you've learned so far, have you ever wondered about the question of how recommendation systems actually function? Well, a recommendation system is like a smart filter that employs deep learning principles and algorithms to propose potential products based on the past preference or additional criteria. The underlying idea behind this algorithm is to identify patterns in the behavior of a user or a similar users when it comes to a particular product or a service. The method by which data is collected varies greatly depending on type of product or service sold. For example, data collected from an e-commerce website would be a review, rating, while YouTube would save liked and disliked videos. There are many ways to build recommendation systems. The two of them are clustering and deep learning. The method by which data is collected varies depending on the type of product or service sold. For example, data collected on e-commerce websites would be review ratings, while YouTube would like, save and dislike videos. Deep learning is a more complex analytical approach that takes input as users' behavior, pattern and filter down the most relevant suggestions to each user. As we have come to the end of our journey, we learned what recommendation systems are, the life cycle of a recommendation system, the types of recommendation system, benefits of recommendation systems, and how does these recommender system work. If this video has been helpful, be sure to like, subscribe and stay connected with our latest content. Until the next time, happy learning.